definitely.
Yeah, he got shot down in Vietnam, and rode the plane into the ground. The ejection seat didn't work, and he was burned so bad that they told him he would never fly again. And in fact, when the helicopter came down with the rescue guy looked at him and threw up.
Yep.
And then the helicopter guy said he had to leave before they were able to get him in the helicopter. And the rescue fella said, "I'll shoot you down if you try to leave." And so he went through 2 years of rehab before he could fly again.
Right.
And then he trained on the SR-71.
Right.
He said that was the only time that he ever got shot down, unless you want to count the bars in Miami.
Okay, Mike, try looking at YouTube now.
There's this joke that they had of speed. They were flying down, I don't know, it was in Mexico, Arizona area, and there was a small plane flying that asked the speed, air traffic control, and they gave them the air traffic control, and then the Navy guy who was flying in the air traffic, in the area, tried to show him up, and gave up, his speed, which is in the hundreds, and then the SR-71 piped in and asked for their speed, and that everybody quieted down after that. It was hilarious. Great stories. He
was doing over Mach 2 when he did an air traffic check.
Yes, right, right. One of the things that they did with it in the Vietnam War was they flew the DMZ line, actually over Hanoi, Hilton, and they flew. They were mapping and everything, but then somehow, they got messages from the prisons to us, and in order for the prisoners to know that they got it, they flew lower and had 2 sonic booms there, twice. So that told the prisoners, the POWs, that, hey, you're not alone.
Good thing you didn't try to do a Morse code message, huh? The sonic booms. So any good radio news? No, they have. I've seen all these hams on my monitor here. I'm assuming those are live hams doing something out there.
Honey baked.
Nobody must have turned on the radio this last week.
Well, things have been kind of rough on DX. The propagation has been quite poor for at least the last week, and actually since probably early in January or even into December. So things are not great there right now.
So what's all the hoopla then with Solar Cycle 25?
Well, it's faked us out, I think. November, things really took off, and 12 meters was great. 10 meters was great. I finished my worked all states on 12 meters during that. So that worked well there. Worked some new DX, but then things really tailed off into December and hasn't gotten up very favorable since then. One thing I thought I could do tonight is show something I found a few months ago. It's a good way to find out what DX is open, what band is likely to be a good one at any particular time. If you'd like that, I can you can share my screen.
It's available for you.
Okay.
Now these are guaranteed for us, right, Dave?
Guaranteed, that's right. Okay. Okay, are you seeing that?
I do.
The map?
Somebody's got a radio in the background. I don't know who that is, but there's a background noise somewhere.
Okay, this is DX Maps. Is that showing on the screen?
Yes.
Okay. Now, with this, DX Maps became popular some years ago, primarily for 6 meters. But especially since FT8 became a very popular mode, it's a very easy way to see what's active on DX. So let's look at the options here. We'll go to PSK Reporter. Still not, since 6 meters isn't active right now. There's nothing showing there. I'll go down to only the last 15 minutes. Still 0 there. Then we'll go to World. Okay, not much happening on 6 meters. But then let's go over to the low frequency, high frequency bands. And here we're seeing 10 meters has some activity out in the Western Pacific. But again, the propagation on the high bands is pretty poor. But you still got some guys off into, looks like Japan and China, working a guy in Chile. But we'll go on down to 15 meters. Well, there's more activity there, but not too much here in the U.S. See one guy up here, and looks like Washington, working somebody down in Australia. But most of it is in South America, off into to Eastern Asia, down into Indonesia, that area. So let's look at 17 meters. Still not very much going on there, but a little bit in the U.S. and again from the West Coast into the Philippines, Indonesia, and of course Japan. And 20 meters, things get a little more active. So you have East Coast guys, looks like, and some West Coast as well, working into South America.
Dave?
Yeah?
All these links are put in manually by the people who are making the calls, right?
What actually happens is that WSJTX has a setting that allows it to forward all of its, every decoded signal to pskreporter.info. And PSK Reporter will show all the activity. For example, if I call CQ, for example, I can check PSK Reporter and see who's hearing me.
Huh.
And that can be very helpful, as you might imagine. If I'm on a band and nobody's hearing me, I'm going to have to swap antennas and try someplace else. But if I see that somebody's hearing me, somebody interesting, then I'll stick around and make the effort.
So Dave, can you filter this? For example, if you're in the U.S., and let's say you just want to hear something from Europe, but you don't want to hear anyplace else, can you filter that?
Well, not really filter it, but you can just go to North America, for example, with the North America map and see what's active there. But we'll stick with the world here. And let's go down and look at 30 meters. This has been a better band lately. See some activity there. 40 meters. Given the time of the evening, more activity on 40 now, certainly than on the higher bands. And let's see. Let me put the gray line in here. That gives some hints of what's going on there. Now here we see a guy that I've been chasing. Where'd he go? Where'd he go? There he is. S79VU and also an S79KW. These guys have been pretty active. This is right on the gray line now. So he's actually been making contacts off into North America. Again, that's the Seychelles Islands. That's one that I still don't have, and definitely been chasing. But this time of night is a pretty good time because here you've got the gray line going across his location, and the gray line is just past the west coast. So there's a decent chance that you might be able to pick him up on the lower bands. So this is the kind of thing that you can use this for. See, if you find somebody who's an interesting station for you, you know whether to stick around or if there's nothing good, swap bands and go hunting someplace else.
So how long do each one of these stay up then?
Okay, this is everything in the last 15 minutes. So these are very recent. They aren't contacts, but they've been received by PSK Reporter. These are recent transmissions. This guy has been sending, and he's been heard by a guy in Puerto Rico, KP4EYT. So you can see he's at least making it into the Caribbean.
So what's the difference in the different color text or different colored labels?
I'm not quite sure what the thing is there. I know when I've been on 6 meters, it'll highlight those call signs. If you send a donation to the guy who runs DX Maps, I've done that, and I show up on little highlight when I post something or when I get spotted on PSK Reporter.
So with the dollar sign and then call sign?
Excuse me?
Where you get a dollar sign followed by your call sign? You donate?
Just the call sign.
So how do you know that they can hear you if they have a call back? One way to do that, probably a better way to see if they can hear me, is to go to PSK Reporter. So here we have all of these things. Now, let's see. Let's see if GW4FRX, let's see, GW4FRX. Don't know if he's transmitting, but he's on there. He's listening at least. No indication that he's transmitting. But let's see if we can find somebody.
You can open up the time period and see if he's been transmitting in the last 6 hours, hour.
Well, here we can see everything that's seen by this guy in Mexico, XE1DUJ. So these things with the little markers on them, those are the ones that he's been able to decode.
So it just goes and looks at that left-hand screen, which is basically on FT8, which is basically everything you're hearing, and just records that into this website?
Yeah, PSK Reporter receives all of these transmissions from people who are using WSJTX. When I'm operating, I'll have a screen full of decodes. On 20 meters, a couple of weeks ago, I had 61 decodes on one sequence, one 15-second sequence. That's a ton. But then I sent all of that information on those 61 decodes to PSK Reporter, and then other people can see that. it's really a wonderful tool if you're using FT8 or FT4 or other digital modes.
And how do you send that?
What's that?
How do you then send that when you see all those decodes? It's up to you then to send that information to the
But it's all automatic. It's all automatic.
Even better.
When you turn on WSJT-X, and when it starts decoding, then everything it decodes goes to PSK Reporter. Not just you, but everybody else here in the world who's using WSJT-X is doing the same thing. So you can see who these people in Europe are hearing. Sometimes they might hear me. A week ago, I was on 17 meters, and it was just before noon, and I started seeing the guys up in Scandinavia were hearing me. It was actually decent signal reports. So pretty soon I heard a guy, or decoded a guy in Sweden, and quickly made the contact. Worked just fine. So I'd already seen him on PSK Reporter, knew he was there, and knew to look for him. So it makes a huge difference, when you're trying to work DX. Okay, any other questions? Okay, that's my contribution for the evening.
Well, that's a great contribution. Thank you, Dave.
You're welcome.
And I like the guarantee, too. All right. Well, I see we've got a few other people who have joined us. Nice to have everybody. And let's see. Who can we put on the spot now?
I don't mind being on the spot. I wanted to show a couple of photographs.
Okay, good.
But it goes back to the flight, if you don't mind.
To the what?
Flight, airplanes.
Okay. Let's see if you can get a little amateur radio part of that too, okay?
Well, just quickly, there's only 2 photos, but I was lucky enough to go to NASA Ames to see this guy as it was going around the world on solar energy.
Oh, yes, yes.
So let me just show this really quickly, and then I'll...
Is that the stork or whatever that was? What was that, osprey or something?
I don't know if you guys can see that.
Oh, yeah.
That's the airplane that went around the world on solar energy.
Full electric.
And I happened to be in Mountain View for our presentation and a tour of the plane. This was a couple of years back. I was on a commission for the industry of Solvay. Solvay was one of the sponsors or chemical company at the time, and I was on a watchdog committee for them. So we were invited to see it. So I just want to show that really quickly.
So is all the panels on the wing, is that where it's located?
Well, there's only one pilot. It's right in here.
And, but I mean the panels, the solar panels.
Yeah, the solar panels are on top of the wing. Yeah, exactly, up this way.
And it must go into a battery situation?
Yeah, definitely. So anyway, I just wanted to quickly show that, and I'll stop share. But I have a question for the group. Since there's a lot of discussion about DMR. So I've been thinking about investing into an HT for DMR, and I just wanted to toss it out to the group. Is it worth it without doing a hotspot?
Oh, yeah. Well, we're putting up a DMR repeater, the club is. And that'll probably be up within the next, month and a half, probably. So, yes, I would say yes.
Okay. All right. They're reasonably priced, and I was looking at I think it's Bridgecom.
Bridgecom, Anytone, TYT, any of those are good radios.
So what's the latest on the Anytone? Is the 878 the latest or no?
I think that's still the latest one. Yeah.
All right. I never did get mine working yet. Remember?
Yeah.
Why not?
I just bought a new. I got a new radio just within the last 6 months. I got an FT2D, and although it is not an FT3D with the big flashy, bright, power-intensive color screen, I'm really happy with this radio. To have the APRS in a portable, config, all of it right here, with the touchscreen, it gives me good radio.
So what is it, Matt?
It does DMR.
What's the model?
An FT2D.
FT2D.
But that doesn't do DMR, does it?
No, it does
It does
C4 FM.
Yeah,
well,
System Fusion.
But it's a new multi-mode, so you'll be able to use either or.
Not with our repeater. It'll just be D-Star or DMR.
So that's another question. So the System Fusion
DMR radio.
Does any digital radio can hit a Fusion repeater, or does it have to be a Yaesu?
No. It has to be able to transmit C4 FM.
Okay, got it.
Yaesu is the only Fusion radio right now.
Right.
Got it. Okay.
And there is a repeater on Diablo now, is there not?
Yes,
not yet. Oh, yeah. Yes, there is.
444.925, what is it?
Yes.
Because I listen to that fairly regularly.
I got a comment.
There is a C4 FM repeater of it.
I got a comment about the Anytone 878. I did purchase one a year ago from Bridgecom, and I have only now, within the last month or two, got it to work. And I have to comment that Bridgecom's methodology and training programs back then was terrible. They'd have a YouTube video, and the guy would scream through it like he knew, everybody who was watching him knew exactly what he was talking about. But that's changed. They've gotten some very good presenters now. And I finally got it to work, and I was on the Pittsburgh DMR recently, and I was over in the South Bay, and it worked quite well there too.
Oh, very good.
All right.
Well, thanks for that report.
Thank you.
It's a bit expensive for DMR, but it's a good radio. It's a great FM radio.
The one that I would recommend is the TYT UV380.
And if you have to buy a Cadillac, you can buy a Motorola SL300.
Yeah, there you go.
Is the cheap radio, and then the SL350 has a built-in display.
So what's cheap for you, Jim?
I actually had a need for the SL300, and I had to get one of those, so what can I say?
Yeah, but what was it? How much was it? How much?
I think it was $400.
So that's getting up to kind of close like the Kenwood D74A.
See, that was what I was looking at. Is Yaesu has a 50-watt mobile that does the APRS, within the back end, and that's a $450 radio. This was $225. I got it used, barely used. So, but if I'm going to spend $400, I want 50 watts.
Pretty hard to do in an HT, though, huh?
Yeah. You have to go to mobile.
Or have it that close to your head. I don't know if I want it that close to my head.
I'm going to talk about that tonight with the microwave stuff. No, you don't want it by your head.
Yeah.
If I can say on DMR subject, we'll have most likely in June. There will be a lecture by Jim Simmons. He will give us a lecture on DMR.
Oh, good.
Good.
Will that be a lecture
that'll be good,
or
right after,
excuse me,
right after the
it will be
repeater.
Yeah, good.
I'm sorry.
Go ahead, Mike.
No, that's all right. Didn't want to interrupt you. Sorry.
No, I was interrupting you. My turn, your turn, your turn, my turn. Go for it.
I said that is a good timing for that because that'll be right after our repeater goes live on air.
Yeah, I'm looking forward to hearing that. I would like to try some DMR sometime.
Yeah, but that's all well and good, but what's the advantage?
So here was my first opinion on it. You know, San Francisco has a DMR repeater. The other day, first time I've ever transmitted DMR, program my call sign into the radio. You know, it knows you can change it to a DMR mode, to the digital mode versus FM mode, and then there's also an auto, so it can follow the repeater, or you can transmit, you know, digital direct to it. The audio quality over a narrow versus wide, it's a digital packetized voice. I mean, I deal with Cellcom and comm systems, and that's already digital packet voice. You know, it's been packaged, but it's noticeable. There's a compression scheme on the narrow, and it opens up a little bit when you go wide, but digital voice, you know, via packet.
Well, part of the advantage DMR is as far as what you can do with it, that you just click on a channel and you can either be transmitting worldwide, all of North America, all of California, all of Northern California. There's a channel or a slot that is for almost everyone or everybody. So, you know, depending on who you want to talk to where, you can make it happen. And you know, you don't have to be, all you need to do is have a DMR repeater programmed in your handheld and go to the worldwide channel, and there you are.
Okay. Very good.
What would be a good source of information on those, as far as videos or et cetera?
Yeah, you just Google DMR or search DMR on YouTube. There's hundreds of videos.
There are hundreds of videos, of which about 50 are worth watching.
Yeah, you gotta.
Yeah,
or maybe 30.
You need to weed them out, that's for sure. But
yeah.
YouTube has a lot of videos on DMR.
Okay, great, thank you.
A lot of folks don't really know how to present a story or a instruction, and you can spend 10 minutes listening to their stories, and that can drive you nuts.
Yeah, programming DMR radios is an art. Let me say, I've got 4 of them. That's the hardest part of DMR.
Yeah, the whole cold plug thing is sort of a high hurdle for me.
As far as programming for the Anytone, you have to use their proprietary information program, and it's a spreadsheet. It's not much different than Excel. However, there's really no simple way of massaging it into something that you can believe or manipulate quickly. It is very crude as far as the spreadsheet is concerned. As far as copying, shifting, moving large blocks of data back and forth, it just doesn't like it. I tried to use it on Chirp. There is a Chirp program, but it is really not too fluid or conducive to working on the Anytone.
It's almost less intuitive than their own OEM programming software.
Oh yeah, yeah.
I'm assuming that those programming softwares are only native to Microsoft or Windows computers. Is that correct?
I can't answer that. I only have a PC.
Yeah, I don't know.
Chirp is available.
I don't know if
I just finished. So you know, with the new radio, I had to merge my old.
RT Systems is developing the software just for the Windows machines. The Apple machines as well now.
Okay, yeah, that's what I was.
But they don't have any DMR radio programming.
The Anytone is not a RT system program.
No. No, there are no, RT Systems doesn't make any DMR radio programming.
Now, the trouble was merging on old old radio programming and channels into the new program, because sometimes their formatting is not the same. So
that was one of my biggest.
It's sitting
problems.
there, and now I've got it into the radio. I need to validate that all the everything's working, and that didn't work right for myself.
I had to re-edit a lot of the headers at the very top of the spreadsheet to make that work.
It was a bad input problem. I just had to re-input some of it.
So, Ed, what do you think? Are you still going to go for it?
It sounds like a lot of work.
Ed, I'll be glad to give you a hand.
All right.
It's going to be for two of us, Mike. You got to have two
I
of us.
just don't want to have to.
Well, I've tried with you, Larry, a couple times.
Yeah, but you're gonna blame the student, not the instructor.
Oh.
I mean, I don't want to invest with the hotspot and all that stuff. I just want to get just the HT. So I'm just wondering if it's worth it. That was the.
Yeah, as soon as we get the repeater up, it definitely will be worth it.
Okay.
I understand with your shortcomings about the hotspot. I've got one here. I've got one of the first edition Sharks, and it's still in use. I mean, it's good to go for me anyway. But yeah, it puts an extra little complication into everything.
All right. Well, yeah, I'm intrigued, so I may actually invest in it. So thanks for that, guys.
You betcha.
Well, if there's any more comments, let's wrap it up pretty quick because we're gonna start right on time at 7 o'clock for our general membership meeting. So, any last minute comments there?
Well, Mr. Patterson, is YouTube working okay for you?
Yes, I you didn't see my thumbs up, I guess, did you?
No, he must not have, but Jimmy gave you a thumbs up on YouTube.
Roger that. Okay, well, the stream is streaming off the ATV repeater just fine also, so we're covering the Earth tonight.
So, Brian, do you still need permission to record?
Yes, I do.
Okay, let me see if I can. I don't hit the record button. What do I have to do? Right click on you? Got it. You're allowed to record now, I believe. Check it and see how it's working.
Yes, it's done. It's
All
working.
Right. Oh, good. I'll send you a P.O. box where you can send the money. So, got a couple more minutes here. Trevor, glad to see you joined us. And
hey, Trevor.
Hello.
You got an update on the DMR repeater? I heard you were up there yesterday, or somebody was.
No, I wasn't up there. Nobody was up there as far as I know.
Oh, okay. I thought Jim or somebody was up there.
Not that I'm aware of.
Okey-doke.
I mean, unless it was North Peak, but no.
Oh, okay.
You're talking South Peak, right?
Yeah, the new changeover.
I haven't even seen the radio yet.
Oh, really?
Jim Moen is still working on it as far as I know.
Oh, okay. I thought we had it in hand.
Nope. I haven't even got it yet. So I've been checking with him and trying to find out when I should pick it up, and he's still having problems with it. So.
Well, there's Jim right there. Hi, Jim. You want to chime in here, Jim Moen?
You got 30 seconds, Jim.
There we go. Can you hear me now?
Yeah, 30 seconds.
Had a couple of setbacks, but it's still going forward. I finally figured out a way to do a poor man's way of measuring deviation so that I can not worry about that while I'm setting the timings. I've done this many times with analog radios. Never have with a radio like this one, and it's a good learning experience. And I'm hoping next week I'll have some good news.
All right, thank you.
All right, let's see what I got to do here to get myself back in operation again.
I'm ignorant. What's this doorbell noise we keep hearing?
That's the waiting room, people entering in from the waiting room. That's just to let you know that you've got people who are joining us.
Gotcha.
So you should be, are you seeing the schedule?
Yep.
There we go, yes.
Okay, good, because it's not really very well outlined here for me. So this is the agenda for tonight, so I'd like to call the official commencement of February's MDARC General Membership Meeting. And want to thank you, everybody who's joined us. I think we're getting the same folks we've seen in the past, which is great. You might want to spread the word for some others to go ahead and join us. I think a lot of people will be appreciative, especially since we probably will be continuing using this Zoom format for some time to come. Any new members? If you're a new member, raise your hand or something so we know. At least we can acknowledge you. Any visitors then? Those who may not be members but are visiting us tonight?
Howdy.
I see a howdy.
Howdy. Howdy, howdy.
Hello.
Good evening. Howdy Goody, is that correct?
Yeah, howdy Goody. KE6BE. I am in the East Bay and El Cerrito. I've participated with 4Cs and Caro Echo and EBARC, and but it's my first MDARC meeting.
Well, we're very glad to have you. As you can see from the agenda in the share screen, we have abbreviated agenda for this meeting so we can get right on into the speaker presentation as quickly as possible. I do want to encourage all members to join us for the board meeting. Our next board meeing is March the 1st, the first Monday of the month. I got a little bit of background noise. First, our board meeting in March would be March the 1st, first Monday of the month. So you're certainly welcome to join us. And I send that out on MDARC's groups.io webpage so everybody will have the link. So I believe the minutes from the last general membership meeting have been maybe not published, but at least routed. Were there any revisions? And if I hear no revisions, then I would like to approve those minutes. So Brian, are you all set with that?
Yes.
Okay, very good. Thank you. So moving on to the officers' report. I definitely will be staying in Oregon for a little while to be with my dad. He turned 100 last week on the 11th. Also got his first COVID vaccine on the same day. And so I'm going to be staying a little bit of time with him, and I'll be leaving out sometime shortly after the board meeting in March. But I will still be in contact via Zoom and email and all the other great technological wonders we have at our disposal. Oops, I see I got a reminder here. Forget the 120620. I think, Kathy, you made that comment to me about changing that.
Yeah, I did.
But so how about we do just put that here, and then we'll just leave that blank for now. So Jan, I'm going to move to you for a vice president's report.
For a vice president, I'm not really sure. Okay. So far, I don't have anything significant reported as a vice president.
Okay.
But as far as memberships, I'm also for the memberships, but I guess I'll wait for that.
Well, we won't probably have a membership thing. So unless you have, if there's something you want to share now would be the time.
I just don't have much to share either. It's I'm looking at 5 plus 1 new members, so 6 new members so far that I'm tracking this year, so which is not that many. I have a little bit more of renewals. So what I will be doing next week, I will send out mass email out to everybody who still is up to renewal of the memberships. But that's about it. So back to you.
So if we can't remember whether we renewed or not, how do we find out?
So I already got it from the agenda from Roger. So I had that. So I have exactly, I know exactly.
Wait, but how would a member find out? Since we don't have access to the database, do we have to contact you directly, or what do we do?
I have the access. I have the database, so I will email to everybody who didn't renew.
So if we go online and try to renew and we'd already renewed, but we get some kind of notification that we had renewed already?
Yes, there should. Well, that's a good question. I will have to look it up because that's. I've been because I've been in there recently and I renewed. So I'm really not sure if I already renewed, if it flags me.
So go ahead and see if you can renew twice, and if you can, then it tells me that probably need to do a little something so that if we ping it, if a member pings it, so to speak, we'll find out whether we need to pay up or are paid.
Yes. So, but for now, for those who have not paid for this year yet, that's clear. I will email them reminders. As far as those who paid and maybe by a mistake they pay again, I have to look at it.
Okay.
It's possible that they will be, if they pay again, like shortly, or they paid 2-3 months ago for this year, if they pay again, they will be logged in for next year.
Yeah, the reason why I say that is because many members are also members of many other clubs, and those memberships renewals kind of all fall due at the same time. So sometimes it can get lost in the in the noise, so to speak.
I see.
So,
okay. So the way I understand it is that if they pay up again after a short time of period they already paid, they will be logged in for next year. And I will have an update for this. I think we are going to update the database, and we'll actually the update will make sure that if they, let's say, pay again or pay again by mistake, they will get a flag or a message or something like that. Do you really want to do it again because you've done it too much?
Yeah, that sounds like. Do you really want to do it again? Sounds like a good kind of message to get.
I will be looking into that shortly, and I think in a couple of months we should come up with a solution.
All right, very good. Thank you, Jan. So, Brian, Secretary's report?
Yep, nothing to report tonight.
All right, thank you. Kathy, Treasurer's report?
All right. This is the report for January. Once again, we had a good month as far as income goes due to generous donations from our members. Our income was $7,744.05. Our expenses were $1,377.40. So for the month, we increased our proceeds by $6,366.65. So between the checking account balance and the savings account balance, we have $70,249.81. Our equipment self-insurance fund is $58,168.04. The Pacificon balance is $14,563.09, for a total across all of the accounts of $142,980.94. So are there any questions?
I don't see any questions, Kathy.
All right.
Thank you very much.
Very good.
Ron, do we get an emergency coordinator communications report?
We're very fortunate. Nothing to report.
All right. Thank you, Ron. So that takes care of the officer's report. I did ask Jim Siemens to speak to the question of the auction, since April has been, and traditionally, except for in 2020, when we hold our MDARC auction. So, Jim, can I get some kind of words of wisdom or words of direction from you, please?
We'll sure try there. Larry. Thank you. Yeah, good evening, everyone. Our plan is to have an online auction via Zoom on April 16th, the night of our normal meeting. We have a number of cool and interesting items that have been donated to the club, and so we'll auction those off via Zoom. We will display pictures, and you can we'll come up with a mechanism for you to bid, and we'll allow you to purchase, and payments will be done via PayPal, and local delivery of club gear will be made available after the auction. And we're also letting you know that if you have some items that you would like to pull out of your closet, so you can sell, so that you can go out and purchase some new items, we will allow that too. So we'll come up with a procedure where you can take some pictures, come up with a little bit of detail, and we'll feature that. You can make your own arrangements, though, as far as delivery with the purchaser, but that's what we're going to do. So this is a kind of a new and different world, but I think it will be fun and interesting, and folks can get out there and do a little bit of purchasing and selling. So it will be a good time. So that's April 16th. Start digging through your closets and your ham junk box, and see if you have some items. And we look forward to seeing you all then. We'll start at 7 o'clock probably that evening. I don't think it's going to be a marathon epic adventure like we often have. So you won't have to stay up late likely to participate this year. That's what I have, Larry. If there's anyone who has any questions or not, and I'll go back in the woodwork.
Well, I think there probably are some questions, Jim, but I have a feeling that you're probably going to flesh some of the how-tos and the procedures sometime in latter part of March, so we're all ready to go in April. Would that be correct?
Yeah, absolutely. We've already been kind of penciling out, kind of roughing out how we want to do this and how it may work. So I think a number of the questions have already been resolved. Also, if anyone has any questions, you can always reach out and email me or call me, and I don't bite hard, so that'll work, and I'm always here to help.
So you would give us a place to deliver equipment. Was that what you would have in mind?
No. Individuals that want to sell, they'll provide us pictures and a little bit of bio of the item, and we will read the description and show an image of the item, and do our normal auctioneering kind of thing. And then after a successful sale of an item, then there will have to be an arrangement between the seller and the buyer as to how they want to get their items delivered from the seller to the buyer. Club items, if you're local, we will deliver those items to your doorstep. Socially distanced, leave it on your doorstep, give you a ring, and let you know it's there.
But if we were going to donate something to the club, we could deliver it to some location?
Absolutely. Please contact me, and I can make an arrangement to pick it up from your doorstep, or you can bring it to either my home QTH or work QTH.
So would you expect from the bio to also include truth in advertising?
No, I don't expect that at all. I've never known an auction that worked that way,
yeah.
but we'll do our best. We'll do our best to keep it fair and above board as far as everyone knows.
So I could have a Yaesu FT5000 that's wonderful radio, but the final sometimes doesn't work.
That's true. I don't think, yes. There's some items we plug them in, but a lot of items we don't, and so we have a sense as to that. But remember, this is an auction. You're likely to get a pretty good buy, and if there is a little defect or there's a little bit of wear and tear, you might accept that for getting a relatively good deal and helping out the club and doing all those good things.
Okay. And we'd also like to get the descriptions and pictures in enough time that we can put together some kind of a PDF document to email out to everybody of what's going to be available.
Yeah, I think I'm thinking, Mike, what we'd probably like to do is put that up on the MDARC website, and as we add to it, it will become fuller and fuller as time goes on.
There you go.
Very good. So, any questions for Jim before we move on? All right, we'll look forward to the rollout on that. So, thank you, Jim. So we've come to the end of what I have on the agenda, and so Jan, I'd like to invite you to introduce the speaker for tonight.
Yes, absolutely. So tonight I have the honor to introduce Mattison Ott, KJ6DZB, on the amateur mesh data networking in 2021. Here, Mattison has 20 years of experience in commercial entertainment and theatrical production. He's a journeyman in International Alliance of Theatrical Stage Employees, Local 107. CTS Certified Technology Specialist. His first ham licenses was in 2009 as KJ6DZB. Currently, he is employed as a senior scene technician for audio and video system at Cal Performances. That's Mattison. So if you are ready, Mattison.
Yeah, let me interject here a little bit, Jan. I've asked the co-hosts to put everybody in mute just because we can eliminate the background noise. If you have questions, I suggest that you jot them down or put them in the chat, and we'll look at those questions when Mattison is finished with his presentation. Okay? So, Mattison, it's all yours. Take it away. We look forward to hearing from you.
All right. You can hear me, right?
Very well.
All right, good. Yeah, I have trouble unmuting myself when I'm sharing. So, you guys got that little introduction of me. About a year and a half ago, I was appointed as a technical specialist here in the East Bay. So I've been messing around with wireless since high school, and I found my way into this. Hey, save the arts right now, because there's still a lot of internet people out there that are not working, and COVID's real. So please stay safe. Hey, but we're amateur radio operators, so if you didn't know, we've got allocations within the 5 gigahertz spectrum. We've got about 260 megahertz worth of spectrum there to 70 megahertz. 70 megahertz of unshared. You're looking at a simple band plan. So this is available as used for broadband and can be used in any combination of high-speed broadband. We're talking 20 megahertz, 40 megahertz. So we're not talking about 12 kilohertz, much bigger signals. So we're utilizing that for microwave data networks. We've also got 2.3 gigahertz and 3 gigahertz at the moment. But these bands are used, at least in Southern California and across the country, for amateur television. So there are amateur television repeaters. I know ours is on 1.2 gigahertz and 70 centimeters and so on, but other hams have incorporated and built systems that utilize this. So aside from high-speed communication, there is also amateur television happening on this. And 3 gigahertz is very useful for satellite ground station, ground to space communication. There are signals there. It's microwave, but it's not too small. It's not 10 gigahertz. Now, we are not part of HamWAN, but I know I've had some questions about it, and they are doing their thing. They're doing their thing up north in this Seattle Puget Sound Bay. But these guys are an example of a modern multi-megabit IP-based digital network. Now, so far, these ham networks, they're being used, it's an IP network, real-time video feeds, APRS, iGating, as well as providing it is IP internet. So people are able to use this as emergency access to the internet. These guys are strict about their equipment. So this is not the Arden project, but they have created a internet RF backbone throughout their region. And you're about to see there are a lot of other areas, but this is not, they are not utilizing the Arden firmware. But across the world, we're going to start to look at smaller areas. But this is a world map. The United States, now this is a list of 900 megahertz, 2.4, 3.4, 5 gigahertz nodes that are reporting to the Arden servers. So that's something you can do. So everybody can find everybody. Hawaii, I'm going to talk about it later, but that's where packet radio really started. These guys are using it to interlink their repeaters across the city. Why not share a common IP network where you can communicate with other radio objects, radio communication equipment? Puerto Rico, amateur radio Arden was deployed to Puerto Rico in response to a hurricane. Why not put up an IP network, and it's portable. This stuff can be deployed. Training, not too hard. We're going to look at a lot of the stuff that it takes to put together this type of network. Southern California, this is the home of Arden. A lot of the Arden developers are based in Southern California, and they've got the microwave network to show it. The Bay Area, a little less sparse, but I'm not just going to say the Bay Area, but I'm talking about the greater California region, because we're talking about statewide communication, communication for counties, but still not as dense as Southern California, which, if we look at this, San Diego all the way to Santa Barbara, there are microwave links. Now, my network might be segmented for a reason or not, but it's there. And, of course, Texas. This is where the HSMM project got going. We're going to look at that hardware. So broadband hamnet and the HSMM mesh. I know a lot of people, we all started year 2000. WRT 54Gs. These were great in 2005, but this is older equipment, and the firmware and the capability of the hardware, well, just hasn't kept up. It's 20-year-old equipment. It was, and it is a very low starting price, limited memory. The software, the DDWRT has grown larger than what can even fit on this equipment. Somebody has an open mic. And then there's low power. There were extremely low power, and like 12 dB. We're going to look at some of these a lot more power. External antennas, diversity, not in diversity. Aftermarket antennas you can package this, but this stuff is not weather sealed. And I'll tell you, with any computer that's using flash memory, it will wear out. So there is a lifespan to this equipment. But it's 2021, and we're moving into much higher data rates. Let's put it like that. We started off in 1999 with 802.11a, B, 11 megabits per second. In 1999, 2003, we got the 802.11g. So we're starting to get faster, but it wasn't until 2009 where 802.11n really allowed us to start getting higher speeds. And we're seeing it now with move to AC and even ACX. We're seeing multi-in, multi-out data speeds up to over a gigabit per second. I mean, you have to plug in a 2 gigabit per second data, hard copper line into some of these access points. But you're able to do mesh roaming. You're able to deliver that speed over the air locally to computers. And we're taking advantage of this now in some of the hardware that we're using. So, like I said, single in, single out transmitters. You transmit, you receive. Your transmitter has one polarity. A lot of this equipment is utilizing dual polarity. It can, in situations, utilize dual polarity, 2 chains horizontal, 2 chains vertical, and it can listen to all of those and pick the best signal. Now, some of the data radios even adapt over some of their long-distance links. They're going to pick a horizontal polarity over a noisy vertical polarity as a pairing. So they can really start to dig out that signal across some of these links. And not only is it's not a dipole antenna anymore. We're dealing with very advanced, yes. On the left is a Starlink terminal. If you're interested in a really cutting-edge phased array antenna, take a look at that antenna and the teardown on it. Ours are just simple 2 chains. So this is the back of one of the power bridges. And 2 channels, horizontal and vertical polarity. But this type of antenna is being the magic in some of the ubiquity equipment. So this is 5 gigahertz. Let me get back to the network. So we all know the internet. It's interconnected networks, that are using BGP, border gateway protocols, OSPF, RIP routing, and the internet maintains a list of IP addresses, and these internet routers need to keep that, and they maintain that. And it's about 750,000 IP addresses that have to be kept in memory. There are different types of routing protocols. So hierarchical routing, retroactive routing, proactive, which is the type of network routing that we're gonna look at that's happening in the mesh, and hybrid reactive. Some of the newer that they're pushing towards a different mesh routing protocol that is similar to hybrid reactive. And let's not forget that the Mars rover just landed, and there are delay and disruption tolerant networks. Information that came back from Mars was relayed and stored and forwarded. So they're networks that predict when and where a signal needs to be pointed in time. Now we're still here on Earth, but as we move into the deep space network, they're sending signals to where they're going to be in 11 minutes, not where they are right now. So you've got to account for that. We're not in that level of advanced RF network, and links, but it's out there. It's coming. I mean, we've got LTE networks and so on, but they're trying to put LTE in space, so it's still viable. But you've got to send information to stuff to be distributed. So it's a mesh. Still coming through. So we are using OLSRD. OLSRD, it's an optimized link state routing protocol. It's a routing protocol that's optimized for mobile ad hoc networks, but it can be used on other wireless ad hoc networks. So it's proactive, so it's looking at the link state, each link, and the state routing protocol. So that floods it floods the topography table. So it gets links, it builds them, sends them to its neighbors. Not all of the nodes on the network, so it doesn't saturate connections through, but 2 hops, they forward that table to each other. So what an individual node is doing is it's looking, it's computing the optimal forwarding paths. Now, if that's to the internet, is that to another node? Usually it's on the network, so you have multiple paths. It's a mesh network. It is computing the best as far as packet loss across the link. So OLSRD, well, let's talk a little bit more about what it is doing. Just get off my screen. Okay. So it's receiving announcements through others, and it's responding with its known routes. So I might be sharing something with Larry because I'm talking with Jim on the other side. So I'm trading that information to him. Jim sees some stuff. I see what Jim sees, but I got to send that information to Larry. Now, I'm also calculating metrics for all of those known links. So we're going to look at some of this mesh, and it gets pretty big. So there are a lot of links that are being calculated, and it happens. It doesn't happen. It doesn't happen instantaneous. So, but it is fault tolerant. Now, an EXT, a metric of 1, represents a perfect link, but it's all uphill from there. Data speed, it's not. Links degrade quite quickly too with ODFM. But we're synchronizing domain names and a list of services, node location, and also that link metric. So that information is being traded across the mesh. Everybody's going to find out what paths people have, what services are listed that they have available. I'm going to mesh chat and WinLink I'm not going to go into those, but they've adopted some backend code that will let them search for other WinLink and other mesh chat services on the mesh. So they will discover and interrogate those services if they're listed properly automatically. So this is a Perl script that visualizes that link path. So as the network builds, you see you've got blue lines are DTD, are nodes that are wired together. Green, yellow, red. We're looking at a link of 1.3 or a red link and a yellow link of 11. So you're very high packet loss on that link. So the more it costs to get from point A to point C through point C, D, and Z, least costs, that's the path that's going to send a packet. They get bigger. This is looking at the entire mesh, about 100 nodes, 120, and it changes over time. This script runs not every 10 minutes, so we can have situational awareness, visualization of that link state. Now, this does not deal with location, though. So this is completely, location data is there, and there's other maps that will visualize the mesh for us on a map. But this is just link state. But this is still useful. So, all right. Are there any questions before I get in? Before I keep going right now? I mean, I can.
I don't see any raised hands, Matheson. Right, so why don't you go ahead?
So enter the ARDEN, the Amateur Radio Emergency Data Network. Community developed code to use this OLSRD routing protocol in a custom firmware image, a custom OpenWRT firmware image. So DDWRT maintains a router, open source router that can be compiled for a myriad of devices. We're focusing on 40 manufacturers and about 40 wireless devices, but there are plenty more that you could load this onto. And we're not talking wireless devices, access points, or just routers. So there's also the pfSense, which is another solution for an open source router OS. The hardware you run it on really does vary. You can have low-grade hardware, but you can also run it on small, very small devices. And we're, like I said, we're maintaining about 40 devices, and new ones are coming along. You've got Ubiquiti, as well as Microtech, and like I said, 900 megahertz, 2.3, 3.4, 5.8. Now we're moving to possibly 10 gigahertz as well. With the potential loss of spectrum, there's other spectrum there. There's open spectrum because it is very difficult to operate with a high noise floor in any situation. Better yet on microwave with a lot of the shared spectrum that currently exists. But Arden has developed this firmware, and over 10 years at this point, Arden has really worked to maintain this, and it is maintained. It's great. So if you're interested in which device you might be able to, the supported platform matrix, the Arden link will be here at the end, but it's a really good place to start. Checking out what devices, how much they cost, because there's a swing, but don't let it be cost prohibitive. We're going to get there. So what do we really do on a network? We know that it's an IP network, so let's just go through a few of the things. Echo link, IRLP if you need to link, site linking, if you need to do voice, direct voice to multiple sites, run the microwave link. You still have bandwidth. Audio is low bandwidth in the sense of things compared to video. Video streaming, though. Video streaming, video surveillance. We were looking at the webpage earlier of all of the cameras that are out there on our local mesh. But it gives you situational awareness, and that can be very important. Remote air quality sensors, gas sensor networks. We've all experienced the smoke, but it is important to get that information. And not to say you're not replacing existing existing infrastructure. You've got other sensors, but some of that stuff is very closed API. We're open with what we're trading. Or is anybody going to be able to get this? I love the APRS weather stations. Just kind of got into that. So drag and drop file sharing, hosting your own cloud, your own service, distributed services, real-time chat. I talked about mesh chat, so you're able to chat with people and file share. I know Howdy, shout out to Howdy, who's also helped me climb some towers and install some equipment. He's running a mesh chat instance, and that's one of the things that will synchronize. So you can synchronize group chat through that. APRS, iGating, if not sending IPRS across a TCP/IP connection. ADBS, AIS relays. You may have a path to the internet, or you may just need to monitor it locally on the mesh. The mode AC, there are holes in that network, or do you need to supplement? Does somebody need, to be able to supplement their situational awareness with the receiver, with AIS receiver? So you can pass that kind of traffic and use these data links to get that to the internet. Remote transceivers and transmitters, SDRs, where you try to do remote receivers, it's an IP network, so you can send that across to an end user. Supporting the amount of bandwidth, these are not low bandwidth networks, but it's also part of the design. Getting that in place, do you need bandwidth between sites, within a ring? Are you creating a backbone and branching off of that? which is something that we really do need to look at when constructing RF links. Self-hosted emailing. Would you like to use WinLink terminals? Or can I log in and send an email through somebody's HF or Vera? Web-based reporting applications, like Nextdoor. Are you able to on your phone, through a Wi-Fi connection, typing this stuff in as it's happening? It's not a voice net. Collaborative computing. We always use Slack, but Slack's not open source, so you self-host that. Computer-aided dispatch, or even mesh visualization, which we've already seen. How do you have situational awareness of what's happening on your data network? Satellite downlinks or distribution. If you have a VSAT terminal that were an internet connection, that you needed to get back through, or a weather downlink. Are you getting the high rate images from GOES West? And needing to see that as it comes down every hour. So, yeah. No thermonuclear warfare, but you can play chess and play games on this. With bandwidth permitting and the latency permitting, and of course with time. GPS synchronization. So I've found over the years running digital modes, FT8, JT65, that having an accurate local clock that synchronizes to a number of distributed other clocks is really important when trying to make sure that your signal transmits at the right time. If you have the slides, take a look here. There is a list. There's a great wiki. We've done our effort to try to provide this information to people so they can find it and read about it. It's a great forum, but Arden has a wiki that will try to explain. They explain a lot, and there's also a forum, so you can get in touch with that. Follow that link. So we have packet. We don't need a mesh. So the history of packet radio. We're looking at technology that was developed in the 60s into the 80s. 1981, we saw really the first TNCs. Plenty before my time. I didn't start off until 1987. So I'm finding a lot of this out for the first time, as well as discovering the history of radio communication, and it's important. But the TNC2, we've hit a limit here. This is the fastest TNC that's around for some error corrected, but for the most part 9600 baud. So it's slower for HF, but this just isn't gonna. This is not gonna cut it for higher. Well, it's not gonna cut it for high-speed communication data. It is not. It is much. Now, I'm gonna jump off here. Layers. So if everybody's familiar with the OSI model, it's an open standard for interfaces. Dealing, in these layers 1 through 7. You've got layer 3 switches or so. Take a little read if you're not familiar with it. But basically, all the way from a physical to a data to a network to the transport. Are we sending? All of the video right now is coming through a transport stream. But this is this open standard that this is how these interfaces are going to work and layer on top of each other. APIs, sockets. Literally down to, these handshakes, encrypted handshakes or authenticated handshakes. There is a difference. So what I want to get at is that packet radio is down at a layer 2 level. So as you climb higher in this, there is more overhead, as far as data that's going back and forth over the link. And at a certain point with these lower speed data links, it is impossible to add higher layers worth of interface. So, the internet's been fast, but has amateur radio been left behind? FM, SSB, digital voice modes, as we were talking about today, are voice modes but they're still at 4,800 bits per second packet voice. You know, it is slow packet. Amateur radio packet, you know, 1,200 to 900 baud in the APRS network. Slow. Vera, you're starting to move. 12K. I had a 56K modem when I was in 10. So, you know, I'm still. Now we're moving on to Arden, where we're starting to utilize higher speeds data. Now, it's a big jump there. 5 megabits to 120 megabits in much wider spectrum. So 5 megahertz, 10 megahertz, 20 megahertz, much wider. Now, LTE moving to Wi-Fi 6 and 5G are going to start moving into 100 megahertz chunks, where you're really utilizing a lot of clients and their spectrum. So instead of single channels, things are jumping around. There's management of that. But a lot, you know, we're getting fast. You know, here we've got this little graph here. Today, we're probably all the way up here in the upper right-hand screen. I have a fiber optic connection run to my house. You know, I easily get 700 megabits per second. I'm not bragging about that, but I think we should all start to expect more from what our internet service providers can provide for us because of modern data standards. We have the ability to get faster internet to people, and especially in rural communities. I think it's abysmal that people don't have higher speed data when the technology is there for us to be able to bring it to them, and not over wireless as 5G. So I want to take an example, you know, and I'm not. We've got a GSM net, a voice net, a neighborhood GSM net. They're talking to an EOC operator, transcribing a message by hand, pencil and paper, all through forms. At best, the EOC is going to have a throughput of one ICS 213 message a minute. So they're going to be writing this down. Better yet, if it's a large list, technical list, transcribing it, not going to work so good for me. I mean, a long list, and there's no way to check that. It's just going to take longer. They run that to the other side of the office, the paper, one message form, another message form. It gets passed through the system 3 minutes later into another pile. Then it's loaded and typed back into a packet network and transmitted back over packet into a BBS. It's listed. It's up there. But 5 minutes later. So I think data can help us send this information quicker, so it's instantly there, and they're moving towards the model of situational awareness. You know, what information am I receiving real time? 5 minutes ago, it's not going to help when you're watching live video. Now, there is a push for more speed out there. The F4 HDK, talking about 500 kilobits per second. Now, this is a modem. This is still an experimental modem. This is manufactured outside of the United States, and to my knowledge, nobody has asked for a temporary exemption to run these radios. They're buying them and using them and testing them. But I think, and as he states, I'm now getting help from the global amateur radio community, and especially in Germany, where they're taking on some of these technologies. But primary use being to extend local high-speed amateur radio data networks to places where two-point microwave communication, line of sight, and radio links don't go. So, you know, we know 2 meters propagates a lot different, and 70 centimeters propagate a lot different than microwave spectrum. They're very line of sight, and that path loss, it's not just height above ground, it's path loss between 2 points, and that can widely vary. So things like this allow you to extend that data link to a client or two within regions within 100 kilohertz signal. So yes, we're using a wider signal, but we're getting data through. You know, we have, which might, yeah. So a packet exchange network, you know, 20 years short of being modern. AX25 packet frames are still only a layer 2 data link. The underlying data mode is AFK. There is no error correction in that. Lacks error correction. It's a logical packet exchange through the network, layer 2, but it knows nothing about the network and who else is on it. Packets are sent or received, then logically digitally repeated, I-gated or ACT. So they do. Now, the originating node, I send a packet. It does not know the best way to send this packet across the network. It's just the next receiver. He knows what he can do with it. It's sent to the internet. It's 2 hops decayed. Now, BBS systems have to be accessed individually and on a unique simplex channel, one person at a time. I mean, you can listen, but one person can access it at a time. There is no sessions. You cannot have sessions with multiple users, and you're taking up an RF channel while they're doing it. Modern data networks, well-established means of high-speed communication at this point. The internet does work, at least most of the time, so it works. You can request to resend data if needed. Now, depending on what kind of data you're being sent, that request to resend might be completely invalid. With live video, I lost a frame, I lost a frame. I don't want the frame now. I want to see video that's happening right now. So some of these protocols deal with error correction, but if you're getting a data set and you request you miss something, resend it, please. Domain names and address lookups. How do we maintain that list of who else is on our network? Who else is announcing services? Domain names, and they allow us to look up, basically a lookup. Routing protocols. So we talked about this before, but data being addressed and sent to the right place and handled. So that's in those. Now, voice networks are slow to send messages, and as we've seen, we are reliant on the internet. I mean, not reliant on the internet, but a lot of what we do today is what we're doing right now is going across the internet. So potential problem there when it fails. Question. So will hams be able to provide alternative means to communication in a modern world? In emergencies. Value added if we can provide situational awareness to agencies who manage these emergencies. The camera on the left, it was a live stream. As we know, Southern California, as well as Northern California, as well as all of California, got hit by wildfires. But Southern California had the microwave network and people with video cameras on their repeater sites. So they were able to set this stream up and send it to the fire captain, giving agencies local real-time awareness. They might not have a camera in the area, but these fires happen over quite an extent. So I know they caught some rocket launches, they caught some fires, but look, you've got cameras in place. You're able to turn them and have real-time awareness of what's going on, whether it be emergency or not. So hams have to step up now because this is a new kind of operator, one that was born on the internet. Wasn't born on the internet, but I know there's other people that were. They're expecting that. So, and people are expecting to have access to the internet, not just ourselves, but I think we have to think of not just emergency service agencies, but also serving a community to be able to make sure they're able to tell their family they're okay if we have a path to the internet to get that kind of communication out there using modern telepathy. So does your local agency, does your local city have a plan for when commercial data networks fail or get interrupted? Part 97 or Part 15 microwave networks are an option, whether we're doing a ham network or whether we're using Part 15. Some of these radios all the radios will work in Part 15. So you can do it in amateur scope, which you'll have a lot less noise. You can do it. There's going to be a lot more noise, but workable. So what if 20 meters or 2 meters were shared spectrum in an emergency? Couldn't imagine that, and I hear, but we can't. Part 2.4 gigahertz has got one usable channel, so because it's completely shared with everybody else's Wi-Fi. 5 gigahertz is crowding in. We're able to currently coexist with wireless internet service providers in our area where we have put up nodes because they're providing service to people within the ISM band. So they have their target. So if the spectrum allocations aren't defended there will be no alternative to a ham network. Yeah, we will lose some of these links because of that noise floor. And I think we all saw what happened in Nashville, but that was a pretty serious disruption to the internet going through there. So now are you interested in joining the mesh? Because if you are, SFWIM. Oh, this is darn. Hold on a sec, guys. Okay. So educate SFWIM, his San Francisco Emergency Mesh Network. So we're interested in education, research, and mentorship of the amateur radio community on digital network technologies. Rapid ad hoc communication, so deployments after post-disaster. A lot of Cal OES says, they get that getting internet to people is an afterthought. They're worried about real-time situational awareness, dealing with the emergency, not necessarily the internet. That is an afterthought to bring that back. They need comms, they need phones through their VSATs, but the fiber optics burned up. Cities not getting, people aren't getting internet in the area for a while, so being able to provide that type of equipment in an ad hoc manner to emergencies. But building out a reliable and fault-tolerant network that may support that, to be able to pipe in internet over a high bandwidth connection. It's there as an asset to the ham community first and foremost, for ATV, for digital video being piped in over hills, from the South Bay to Mount Diablo. You've got that bandwidth there that can also be redirected in an emergency to support internet telepathy. So if you're interested, SFWIM, though, we've got a great setup about this. I'm not spending a lot of time tonight on the details of it because I want you to come with us on this, and we will get you in the basics, the concepts, what to buy, and how you can tailor this to your served agencies, because we're growing out of Berkeley, we're growing out of San Francisco. This is a regional effort. We've got a larger region here, and also an OES district. We're a greater area that needs to pipe information into our counties and to the people that need to deal with a potential disaster in our area. So let's get them what they need. Now, let's start to talk about building this network. So there are a lot of potential problems with establishing a microwave network and microwave relay sites. So rotating obstructions. Up until last month, these ships were there. They're no longer. So all overnight, ships have to sail. The crane that rotates in and out of the line of sight is gone. Didn't work like that for the last 4 years. But sites don't always have good coverage. We live in an urban environment. Repeater sites, though, are key to regional coverage. High elevation to low elevation. Bonus prize is somebody. So here's the question. We all know 2 points on the surface of the Earth get about 40 miles. But what kind of distance do you get when you're at 3,000 feet? How far can you see? Quite a difference. So high elevation gets us signals into valleys, into regions. But no location is perfect. There's always going to be something wrong. You're never going to have an omnidirectional coverage pattern. Well, I mean, maybe on the top of a mountain, but even then, the tower's in the way. So that's gonna affect the antenna radiation power if you're trying to use an omnidirectional antenna. Maybe not the best choice. So access, line of sight, RFI, HF. We're co-located with other radios. There are some problems at times. RFI, HF you can mess up radios. But also mounting power considerations. Where's your source of power coming from? And of course, channel segmentation to provide the best throughput. So let's take a look at this. We've got the hidden transmitter syndrome or exposed receiver syndrome. This is from ARDC, and they did it perfect. You know, we can't all transmit on the same simplex channel and expect to hear it. There are some protocols that let us time it. You know, I send now, I wait. You know, I send down the minute, you know, or so. But you do get overlap, and you have to. You can't run everybody on the same simplex frequency. Let's put it like that. There is a methodology that Arden lays out, and part of our band plan has accounted for that, keeping San Francisco on a different 10 megahertz channel than, or having different sites or Treasure Island. You know, that's a different vector, and I tend to work them as vectors because it's point between 2 points, but it's in three-dimensional space and it has path loss. So there's things to work. Types of antennas, cross bay links. So keeping radios that are within ear range on separate channels in order to not have some of the problems of flapping nodes that are there and not there, there and not there. It's not polite to the routing topography. So, okay, safety announcement. We are using a legitimate amount of power. You know, we're using up to 50 watts, you know, 25 watts. Some of these higher gain, some of these radios, once you pair them, you know, transmitter power plus the antenna DBI, the Rocket M5s, you're starting with a radio that puts out 27 dBm. You put it into a 30 dBi antenna, dealing with some power. So I wasn't playing before. If you're going to work on this stuff in your house, if you're working on configuring it, one of those first things you do, go in, turn the power down. You don't need it on your bench, putting out that much power. Once you get to the radio site, turn it up to an appropriate amount. As I said, we live in an urban environment, though. Trees, cranes, not enough elevation. Everything on Google Earth, everything in Ubiquity says you've got to find point between UC Berkeley and your Chris down in southwest Berkeley. Not when I get there and the eucalyptus grove's in the way. So there's something valuable to be said when you survey sites. We're not just talking about running the math. We're talking about a visual survey to try to visualize point to point if there are going to be obstructions. Are there going to be things in the way as far as the Fresnel zone of the antenna? So I hear you, but you don't hear me. Or, like I said before, flapping. You have marginal radio propagation. There's a signal there. It's not. Shipping traffic on the bay reflects radio signals. So bigger ships, you get that point where signal's bouncing off of it. They go away, it's gone. So there's some interesting things we found out about low-lying microwave signals across the bay. Directional antennas start to clear that up. So a directional antenna might be appropriate versus an omnidirectional antenna. It's something you really do have to look at. Truly, line of sight and reflections do take place off large surface objects, and path loss, and once again, the curvature of the Earth. At a certain point, shooting south into San Jose from Berkeley becomes impossible unless you're at 3,000 feet. So you see some of the higher ridges up there, Loma Prieta. Those things are just above the horizon for me here in Berkeley, but shooting across the edge of the bay is not advisable. There's a lot of variation in inversion layer and temperature that will create a fluctuating path. Be warned. So directional antennas. We're kind of looking at antenna patterns. Ubiquity is really good at describing their antennas and letting you know sometimes. Some of their variable antennas, we had to do our own testing. But there is a difference between a directional antenna versus, some of their let's just take a look at the nano stations versus some of the nano bridges. So a sector antenna might have a very wide pattern, but we're doing it in three-dimensional space, so that is a very narrow beam. And then you tilt that down, and you're not. It's in three-dimensional space. And some modeling programs, as far as this, have trouble with it when you're not taking a horizontal plane and a vertical plane. But if you tilt an object, you turn it. So just remember, these antenna patterns will get you. You know, we've got sectors that you can point them down at a city at 45 degrees, but you're not going to get anything at 0 degrees across the bay. So, and some of that is setting up what works for a certain site. What coverage do I? What visual line of sight do I have? But there's also the big antennas. Ubiquiti really steps it up with 30 dB all the way up to 37 dB. If you want to pay $1,000 for an antenna, but it's going to get that signal a lot farther. And path margin is helped. And rockets let you kind of play with that antenna directional sector, as opposed to some of the nano stations, which are great for medium distance links. Great coverage pattern, but it's not a directional. So it's definitely not going to put out as much signal as that is. Part of these panel antennas, though, is that this is the antenna I was talking about before. We're looking a little closer at it, but all it is a rocket stuck on the back of this antenna, put in a different shell. So they're standardizing this radio equipment. You know, they're making. We're not the only buyer of this stuff. So it's modular, but these are great antennas. It's amazing to watch, to have taken some of these apart. They break, so we have to take them apart. You know, so, it makes them inside. Great looking stuff. So omnidirectional antennas. You know, you can't aim them. They're not directional antennas. You may need a directional antenna to overcome the path loss to hit them, but very high gain along that 5 degrees of their beam across the horizon. So you try to put that on a tower at 3,000 feet, that may not be the best appropriate antenna for somebody that's down below at 45 degrees. Just got to look at that. Now, what I'm going to get at is not every antenna, they're not all the same. Each one responds a little bit differently. They're built a little bit differently, and they're not tunable as we're used to with our HF with larger antennas. These are some S11 sweeps. Like I said, we had to actually do some tests on the antennas. One of them is the omnidirectional antenna. The green beam, the green blocking, is the ham spectrum that we're utilizing. So that's our ham band. So we can kind of see where they fall. So it rules out some antennas, or it rules in some of the configurations. Some of them are variable beam width. Oh, put it in 60 degrees, and we get a better return loss. So we got to start looking at sites. This is the northeast bay. It's still in the east bay, but as you start to plot sites, possible objects, and I'm deep into Google Earth with sites and possible receiver sites and talking to people and working different things. But it's a good way to keep track of it. But it is not. It helps you start to visualize where. Looking at an East Bay to South Bay link, we can utilize Ubiquiti's AirLink, great web application. Go in there, put in the type of radio, put in the type of antenna. Their antennas, their radios. I mean, you can put in dB and kind of budget, but for the most part, it's their equipment. So it's a very good metric of what data rate they expect to get for that path loss. Works great in open space. Like I said, these HAT models don't account for trees, cranes, urban terrain, but they do count for height above ground. But you have to make sure that that path loss is accurate in there. And if you have, trim a tree, you can do what you need to do, but high elevation is good. So we're starting to build microwave sites. This one, simple, a 2.4 gigahertz radio and a 5 gigahertz radio. 24 volt PoE. You'll plug the two things into each other. Anything it hears on 5 is going to get. There's going to be a packet channel. I mean, there's a path to 2.4 gigahertz. So you could put this up at your house. Run the cable. Simple advantage. Simple demonstration. Photo on the right is the USS Hornet. So there's 2.4 gigahertz on the left, 5 gigahertz on the right. One's pointing in one direction, pointing in the other direction. Radio separation is a real thing. I'm not going to point. It is bad practice to try to point two radios right at each other, even if they're pointing in different directions. Why can't you put them back to back? I mean, the dishes have rejection, so utilize different frequencies. Now, you can use the AC adapters, but there's also an awesome line of powered PoE switches that you can use that alleviate all of that, all that clutter. We like to keep it simple. I mean, they send you some stuff, but you don't necessarily have to use it to power the radio. So let's think about power, though. So it comes with a supplied 240 volt, 120 volt that makes 24 volt PoE injector. That'll work, But with some of these larger systems, and your computers at home, I hope you all think about, what you're doing as far as battery backup or soft power off so you don't damage hard drives. What do you need to stay up? How long? Is a UPS going to work? Do you have solar at your house with a battery system that runs on 12 volts, runs on 24 volts? How much maintain charging for it, or is it a small node where there's just a simple 12 amp hour gel cell, single radio? That's a perfect pairing right there. But might not need a $200 PoE switch and charge controller in order to get that simple thing to work. So, but power consumption margin, I think you have to take that very seriously with this stuff. We're running it off the grid. Are you going to have each radio is about 8 watts. You can push them up to 11. They actually burn more power when they're not connected than when they are connected. Having the solar capacity, though, winter and summer capacity. Sun goes down, when sun dips, you're looking at a lot less hours a day to charge your system up. Do you have the battery capacity? Is it worth the investment? Lithium ion, are you going towards a newer technology, battery chemistry? You're going to pay an initially up front, it's going to cost you more, but build a large enough capacity, you're not going to damage the battery system is going to last longer. So it's a possibility. But lead's still it's still cheap, for weight. But you're going to so there's some advantages on that. Weatherproofing, make sure you weatherproof, because water and electronics don't mix. So take it seriously, whether it's with the cable. We're going to look at that, but waterproof, please. And if you can, when we're talking about solar panels, a 100-watt panel is not necessarily going to be completely efficient and get you 100 watts. SunPower, Renogy, these guys they're making high-quality solar cells, and there's a difference between a $50 panel that comes from China versus an American cell, some of these high-efficiency cells that are new monocrystalline technology. So look for the good panels. It's going to pay off, as far as surface area, power efficiency. You got a 100-watt panel up there, why don't you get it, pay some money for it, but it needs to get you a proper amount of power. Cable. So we're all used to dealing with Cat 6, UTP, unshielded twisted pair, with crosstalk protection. Well, Cat 5 and Cat 6A they're standards, but they're still unshielded. The standards do not specify shielding and how impervious it's supposed to be to RFI. Cat 7A, crosstalk, EMI protection within the specification, and overall cable shielding. So we're starting to get it at Cat 7A grade. But we don't need Cat 7A grade cable. So the photo here on the cable on the upper right is a Cat 5E grade cable, but it's a double shielded burial grade cable. So on top of the Cat 5e specification, double shielded, ground lead, and it can be buried in the ground. That is not part of the wireline specification. So you have to be careful with your cable and picking it. The Ubiquity Tough cable works. It is the right grade of cable, but it's single jacketed. So there have been some problems with it. Weathering. Plastic does dry up when it's outside. So UV hardened cable is not going to degrade because, well, it's not the specification that's going to get you through it. It's getting good cable. So we've got some stuff for you. We've got plenty of stuff, equipment. Shielded connectors, and also you may need to proper grounding. Please, ground things properly. The Ubiquity equipment has a tendency. Part of the function of the reset button is actually run through the cable. So if you short out two of the cables for 10 seconds or 30 seconds, you will induce the firmware will reset to default, or it will or it just resets. So you have to be careful with that. People have ferrite works. You got to get the right mix. If you run into that problem, well, you'll run into that problem. You'll find the weakness in your data wiring, but it is fixable. Toroids, different grounding. We'll help you work through it. A lot of people have run into it, but it's something we can help with. People have experience on it. So, picture time. Let's start looking at some install sites. This is the WA6KQB. Shout out again to Howdy. He was their ground support for a very, very windy day to put this up there. One of the simpler, it's up the tower at 100, up 50 feet, but still, 3 nodes, an IP camera, using the stock PoE injectors, and a managed switch. So part of some of the configuration is using 802.11q to do some port tagging to allow you to use one line and have the WAN, a mesh LAN, and also a direct DTD, a direct-to-node communication as far as packets. So you can keep that separate. But you'll need a managed switch to break some of that out. You don't need it to just plug into a node and connect to the mesh. So you can plug it into your laptop. So they've predicted some of this. This is the site up at KPFA. This is I'll only know him by first name, Chris. This is a site that's going to be looking right at Mount Diablo soon, and hopefully an RF link between it. So, sometimes we get to climb on towers. I like climbing in the dark, but I also work in a theater, so I like the dark. Climbing on a tower is not too bad. Stay safe, please. Use your proper safety equipment, please. This is overlooking, or not going to be seeing horizon shots, but a dish, point-to-point link with sector coverage, and the camera's down in there. This is the Coast Guard Auxiliary Station with the giant Yagi. There's a beautiful antenna. If you can spot it's just up there at the base, at the joint. There's an omnidirectional antenna up there. This is the left is the Richmond Field Station. Just 2 nodes, a panel antenna shooting across the bay, wide coverage. Get a little more serious. This is Southern California. So a number of bands, point-to-point, sector coverage on 2 meters. I see 5 gigahertz there. And there's also other microwave link. We're in our ham spectrum, and we are out of their way. That is the one thing we are finding. Another view from a tower site, but once again, a view of a fire, being able to see things in real time. Some left to right, people getting simple tripods, put it on your roof. This is the Microtech LHG, so it's a 5 gigahertz dish. You can get them for about $75. You can get them 2 for a pair. But you're going to pay for shipping. This stuff comes from overseas. So little weird with the supply chain. And so COVID-19 has disrupted some of this equipment, and making it easy to get. Look out. You can put it on your roof, temporary, for the weekend to get it set up so you get something more permanent. Solar sites, off-the-grid sites. This is a fire station in San Francisco. This is Greg, Isaac. This is the SF WIM team putting it out, getting in there, and this is an omnidirectional antenna. But like I said, if you've got to go for Omni and you're not looking for that long-distance link, there's people everywhere. So broad signal. If you can only put one node up at a site, you just got to go Omni. Well, unless if you have omnidirectional coverage. The left is a 3 gigahertz site down in Southern California with pan tilt zoom camera. That's. I asked for some pictures. One little trick thing you can do, you can use your dish TV. You can buy KP antennas, performance antennas. Will sell little modules, little ABS injection units that you can put a nanostation in front of a dish. Some of these small 70 centimeter satellite dishes. They do, frequency permitting the size of the dish. It does have some gain and rejection. Right is the UC Berkeley. This is the top of Evans Hall. This is a system that is completely off the grid, omnidirectional, 2.4 gigahertz sector, 5 gigahertz directional. With the Ubiquity solar switch, you're limited to 4 ports. But this was an amazing thing that I found. Well, I didn't find it, but it showed up. 4-port PoE. It's a switch, so it's 24-volt passive PoE, and it has locally managed Wi-Fi, so you can turn that on and turn that off when you get up there. The internal switch does jumbo frame paths, so you can get those DTD frame packets where they need to go without any configuration, which makes it easy, but you're limited. It's not a Cisco switch, but it's also got solar charge management. So you can plug your batteries in there. This system's about 75 amps, 100-watt panel, and it's been off the grid. We're working. Our first system up here, this is about the third time we've had to go up there over 7 years or so. First system ran for about 380 days. But the next year around, you really do have to watch for the battery degradation as well as the sun. We do end up with less than 6 hours of sun a day. But thanks to Howdy confirming that this is the right mix, there are a lot there. You can do. There's solar calculators. You can calculate potential power, what you can realistically collect and create that margin, because you're going to need to do it if you want the system to maintain itself for longer than a year, 2 years, 3 years. So it's a good thing to think about. You don't have to run this off batteries. You can run them off, you may have 120 volt system, that's already, you just want 120 volts. Fine. Use the PoE injectors. Do your thing. Or, like I said, a PAN, a personal area node, something you can carry, you want to carry one of the batteries in the node. Something, if you got to deploy a system on the spot, a single node and a camera, an IP camera. One of the things SF WIM has been doing is supporting some of the races. Races, maybe not a race, or just a run, or a bicycle ride. Cameras, real-time situational awareness. So back at net control, okay, there's the runners. I'm watching it real time. A little bit messier, I'm sure that's not my equipment, but this is OR down in Southern California. You got to lay it out so you can get to it. You don't really want to dig around. We don't all have networking cabinets at home. So make it neat, make it work, do it properly. Field day. Field day is a good use for mesh if you're within coverage. for 2015, 2016, 2019. 2020 didn't happen. So, but we're able to provide internet as well as local Wi-Fi, a local network for logging, mainly logging, so we can all keep track of our contacts at our field day site, which is down at the Berkeley Marina. If you want to come, well, when things happen, we don't really know how it's going to pan out. So it's upgraded. There's a Rover Mark II on the way. That one was stolen. They didn't get the radios, but they've got a new one coming. So field day will happen again outside. Just don't know how it's going to happen this year. So great way though to bring in internet. So if we were talking about 1981, so in 1981 the internet really happened. The people that got those, the smart people that were like, we're going to make this internet happen, got together and made the internet happen. Well, AMPR, ARDC, had a chunk of those IP addresses. So, you know, of that 750,000 IP addresses, that those internet IPs, very valuable in 2000, very valuable because there are a limited number of them. They've eventually sold off some of those 4.4 addresses to Amazon. Correct me if I'm wrong, and have since been holding those funds in trust, and were gracious enough that SFWIM applied for a grant and received a $100,000 grant from ARDC to educate, research, and provide the mentorship to the amateur radio community on digital network technologies. So this is coming to you because, you know, in 2021, I think we're still we're finally making a push to create an amateur network, an amateur intranet, you know, within our own communities and throughout our cities, our states, and our counties. So I think we really have the chance to do this. And you saw that map before. It's really moving. So rapid ad hoc communication deployments that can be used for disasters and emergencies, and reliable and fault-tolerant networks that really do serve to protect our county and our residents, you know, our people. So we're moving towards creation of centralized infrastructure on some of these hosted services. So some of the mapping systems, if file sharing, ideally to put them in your, you know, within your city. And this is something you have to identify, you know, through what does your served agency need? What is some of the situational awareness that you might be able to provide through these links? But to provide to place this stuff at hardened key hub sites, redundant power, whether it's solar, wind, and the monitoring of it. You know, is it okay? Weather data, weather networks, and people were playing, or, you know, nobody really wanted to spend $100, you know, $150 on those spot air sensors. We could build our own. You can build your own. So, or providing an infrastructure for. There are a lot of research projects over here at UC, a lot of air quality studies. Do they want to put a camera up on your? Do they want to put a camera on your repeater site? Do you have the bandwidth to be able to get that back? You know, pipe that to the internet for them, for their need for the data, you know, for whatever they're monitoring. And easy and quick deployments. You know, we may have the chance to put up, you know, some of this backbone, but to really make sure that there's equipment ready to go to be deployed to a staging site within a city. Is it already there? Are you pulling out the phones? Are you getting the phones, you know, and cameras set up? In addition to there already being backbone coverage into a region. So what can you identify there? In Pelican cases, you know, powering them, Wi-Fi gear, you know, generators, and really empowering you to configure it and have it ready to go. We don't want to be configuring this stuff on the fly. So, and moreover, the grant envisions this being broken out into phases, you know, and with the exception of sharing infrastructure. Not just San Francisco, not just Berkeley, not just our county, but we're inside of a OES district. There's a flow of information, and we want to be able to support that because I don't think we don't have as much redundancy as we think we do in the internet. So be able to provide that within within the ham community is going to be a long-term asset, and we're going with it. You see how many people are adopting this? This is insane. So, the telepathy across countries and regions. Well, country, I don't say we need to connect this mesh to California. Let's just start locally. Your city, supporting what you need to do. We want to help organize some standing committees across the region. So within San Francisco, CCSF, the East Bay, the South Bay, Palo Alto has stepped up. They're interested in some research regarding this within their local cert, and also the North Bay. So East Bay, South Bay, North Bay, San Francisco. These committees we hope to empower you to deploy sites within NMesh equipment, including hardened hubs, and build a relationship with your local served agencies, and help them and connect them onto the network. How they may need it. Supporting these regional will be standing committees, project committees. We'll work to define and build things like shelter kits, environmental monitoring systems, core infrastructure as needed on a basis. We need to really determine what's gonna happen. Systems. So we have our first meeting. I'll put the link out. Ask me questions, but we've got a meeting tomorrow regarding the East Bay. So if anybody's interested tonight, kind of come on through. We're looking for at least 3 people, so we're still looking for some hams in the North Bay Napa area. I'm doing a talk next month with the Valley of the Moon Amateur Radio Club, so it'd be great to reach out to them. I don't live up there. I live in Berkeley, so the commuting. So we're looking for people. If you've got somebody who's interested in mesh, locally, but we also want to talk to them regionally. We've got some people in Sacramento, as well as up into where are we pushing up to? Up into the Nevada City, Grass Valley area. So, and we've been historically connected all the way up into Redding over the internet. So, did I get the last of what's on this? So we are looking for people, but we've got about $30,000 to spend in the East Bay. So we're looking to you to help bring in, and we can really get this going and deploy this into some of the communities for served agencies. So we're looking for nominations. If you're interested, the committee email here, send an email to Kylie. She'll get you into the mix. We're also running a Slack. So if you're interested, go to sfwim.net/start, and that's going to get you channeled into Slack, where we're constantly going at this. So we have to take days off when we do work, but kids and dinner. But it's a great way to stay connected about this. East Bay at sfwim.net is an email that will try to filter things through, but Slack really is the way to do it. And this was set up through SFWIM, so they're working for us. ardenmesh.org. Get to it. That there's a lot there. There's a lot there. And I know I didn't go over to the basics of networking. So Santa Clara ACS has a presentation regarding it. It's a little bit simpler. I just didn't have time for that. There was quite a lot to talk about tonight. So thank you very much. This is KJ6DZB. I'll be done. Are there any questions?
Okay, there is nothing in the chat right now.
I see a hand. Jim's got something.
Okay. Oh, hi, Jim.
Jim.
Go ahead.
Jim.
Okay. This is a great presentation, Matheson, and I want to thank you. I learned a lot, but I also learned how much I don't know. I guess the question is, I've been watching from afar kind of the whole mesh process, and as you pointed out, it's been going on for a while. And Mike, what I'm hearing today from you is it's all coming together. It's all starting to work, and I guess it means that I really should be taking it way more seriously than I have been. What I'd like to ask you is kind of where do you see, now that it's kind of getting organized, where do you see the thing, where do you see these efforts in like 5 years? I don't want to go out 10, but how do you see it going from here?
Well, I'm concerned that it may take. I'm gonna theoretically, 2 paths, because I think we're facing a dilemma right now where we will lose 3.4 gigahertz to Wi-Fi to 5G. Question is whether it will be shared, whether we'll be able to maintain some shared sense of shared spectrum to still utilize the equipment, because part of the what's made this work is the access to this CPE equipment, the ubiquitous amount of equipment coming in from still in the used market or new, old stock. That it's made it easy for people to get this equipment. It's not a $500 radio. It's a $100 sub-$100 piece of equipment. You've got to get set up, but we've got the resources to get you cable and stuff. So by losing spectrum, we will be forced into an unknown at this point. So do we continue to have the spectrum to be able to have multiple channels in 5 gigahertz, be able to really continue to expand and have that flexibility to not overlap with ourselves? I've given as long as we're able to get people interested and continue to put up sites and get this radio and have have new equipment still available on the commercial market, where it shall be, the hope would be that there can be backbone through Northern California to Southern California. It's been a goal of Arden, in the Southern California, to be able to get into EOC. Remember, that's the get information through California. We know Cal OES. Counties have the microwave links, they have the sat links, but they're not relying on any of those things or any of those services as amateur services. So if we're able to really have our own data network for amateur purposes that can be utilized, that's what we're doing. That's what people are doing. But it isn't. It's got to grow. It's got to still continue to grow. People have got to get, well, as we saw in the picture with the Bay Area, the Bay Area region, people have tried it out. They've got it here, they've got it there. But it's making sure people understand what they can do with this. So, and the other alternate is that we lose our shared 5 gigahertz spectrum. It's noisier. Some of these long distance links, that path margin, more noise, more Wi-Fi 6. We lose 3. We've got 1 channel on 2.4 gigahertz. So we've got to buy new radios that don't exist at the moment. Well, or cost $1,200 for a pair of radios that don't run the Arden firmware. Now, that's not necessarily a problem, because remember, we're dealing with an IP network. We can do packet tagging. We can use new high-speed fiber 25 gig, 60 gig stuff to create links and still have this the mesh IP space exist and transit through. So, and it could transit over a Starlink, tunnel, through the internet. It's feasible.
Okay, Mike, W6MEW has a question. Mike?
Yeah, Madison, I understood at the beginning that SFWEM is just going to be using MikroTik software. Is that correct?
That was the ham WAN in Puget Sound up in Seattle area.
Because there's some of us that have already been set up with Ubiquity hardware, as you can see behind me. Mm-hmm. That's my antenna array on the roof of my house. Yeah, I just misunderstood what you said then. Thank you.
Yeah, I wanted to be specific. That is an example of hams creating an IP backbone through their community. But their backbone is not utilizing the Arden sauce, the Arden OLSRD for routing. It's using another, because remember, this equipment it's completely functional without us taking it over. Mm-hmm. In fact, it works better over-the-air high-speed data rates than what we've put to it.
Okay, Wiley, KF6IIU, you're next.
Yeah, that kind of partially answers my question. My question is, did you evaluate the performance of these units like the Ubiquiti equipment as is off the shelf on the unlicensed bands versus modifying them for ham radio?
Right. And right now, we're utilizing some of the off-the-shelf equipment, air fiber grade Ubiquiti equipment. So the air fiber, which we're looking at data rates up to 800, 300 megabits per second versus the limit of 70 with the generation of equipment. So we're looking at higher speeds because it's a new generation of equipment, and we're using an older generation of equipment. And even part of the roadblock that Arden has had developing is the openness of the manufacturers. The drivers are not open sourced.
Right.
There is an open source implementation of 802.11n. There is no open source driver for 802.11ac. So right now, some of the Microtech equipment will work out of the box stock 802.11ac. You put Arden firmware on it, it will not use that modulation scheme. It will only use 802.11n because that open source driver is
What kind of ranges have you gotten from the air fiber equipment?
It is mainly dependent on path loss.
Yeah.
And height above ground, and that path loss margin, and the curvature of the Earth. So we have a few links plotted out to install, but 5 gig. I can't give you a direct answer on that, but I tell you, 5 gigahertz really does propagate if you can put enough signal downrange.
Yeah.
So,
okay.
But 25 kilometers. We're talking being able, if you look at the map here between this upper dot Nelson Bronte and over to Mount Diablo, the path margin is there. But like I said, you're trying to get as much gain in that path margin for ODFM to ramp up its data rate. So some of it is you have a very low signal. It is going to lower its modulation scheme and run at a lower data rate. So you really trying to get as much margin signal for the mode to pump data through. And part of what air fiber does is manage that. The asymmetrical transmission over 40 megs. So you've got to transmit one-way signal on a 20 meg channel and the other direction on another channel. So you can have asymmetrical transmission and filtering. So you can really start to flow high-speed data through that link where you're getting gigabit per second over the air with.
Great.
John, A6ZT, were you putting your hand up and waving, or were you just scratching something?
Well, I did have a question.
Take it.
Assuming you have good line of sight on these long runs, how does atmospherics affect the signal quality and data rate?
It's not as bad with open air signals at 5 gigahertz. What we're seeing is objects in the way, and of course that low level moisture. Moisture is going to affect it. So when we get rainstorms, we get some of these heavy rainstorms. Things are blowing around. Sorry, the question again, what was that?
Well, I think you answered her. It's just how does atmospherics affect this?
Yeah, and they do, and they do. That's why it's path loss. So the farther we get away, but we really can do 20 dB, 20 dB antenna versus a 37 dB antenna. You're putting out a lot more power over that margin, and some of this is buying the appropriate antenna for that type of link.
So with that rate, there's enough headroom to guarantee a fairly decent signal.
Right, and that's what the Ubiquiti tools, the Ubiquiti Air Link allows us to do. Is what is their calculated? Yes, it's some of their proprietary tools. Yes, they allow us to look at data rates in the radio.
And Madison, could you give us again the name of the San Francisco group? the mesh group in San Francisco?
SFWIM. I'm going to bring up the...
And that stands for what?
San Francisco Wireless Emergency Mesh.
Okay. If you have any other questions, please raise your hand within the Reactions tab. Put your hand up so it will show up on the image. We may not see you if you're just raising your hand and your thumbnail there.
Okay.
Particularly since it covers multiple pages.
Mark has a question. KD6MZC.
Right.
Okay, yeah.
It's more of an observation, and I've dabbled with mesh for a number of years, and I think it's maturing in great ways. I personally don't see the technology, which mode is best or what the big issue. I mean, sure, we can worry about it. I think that the big challenges in the near term are getting more density of nodes so that the mesh really works and it doesn't have blind spots. And then I think the other challenge is getting services on the mesh and getting them coordinated so that people can actually do something like send files or email to other nodes.
Yeah, and I think, part of that, is there are not necessarily a ubiquitous number of hams in our city. So we're ultimately limited, but I think we can do our due diligence to talk with our schools and of course our served agencies, but the University UC Berkeley by getting some of those sites, our other amateur radio clubs to really work at how they can bring this forward as a new technology in amateur radio. And I think the other challenge though is we've got to interface. Some of these served agencies, I don't think they know that we can offer this. So part of it is a very high level, technical, discussion with some of their IT, and or if the fire captain understands that level of of what we could provide and what services specific, very specific to every user, what they need, or we're providing them video, more than willing to host, to find a hole or an amateur repeater site where we could put up a camera that would be an asset to them. Or is that something they need? Fire watches, wind warnings. The install at Chabot, the camera there is a pan tilt zoom camera that allows the radio club to monitor that camera and use that camera to look around. So they don't have to be there. So, but it's looking for services.
John A6ZT, did you have another question, or is your hand
yes.
still up?
No, I have another question too, and it was kind of a follow up on that last answer. Is there, you have a map here of some service routing. Is there any map available that can show us where the amateur service is in conjunction with what public service is existing now between different interagencies that we might be interacting with?
You mean with
well, like fire departments, police departments,
their radio links, their microwave links?
Well, I assume, I don't know for sure, but I assume that there is some link within the community of cities, towns, and counties that, and even the state perhaps, that there is some digital interlink between these groups.
There are.
Is there any overlay that we could see or look at online to see which is there any redundancy there, or is there any repetition there? Is there an advantage which gives this effort the amateurs are doing an advantage to help these groups out?
That is a very intensive technical exploration. I mean, it would have to be undergone. Some of this is security. I mean, they don't share this. I mean, we've got some general ideas of where the fiber optic lines, go into the ocean, but some of this with RF, it's a matter of literally at sites. I mean, I know Alameda County has their sites have microwave links. But some of this stuff is they're not going to share their infrastructure, data infrastructure, for whatever reasons, for security, with us. At least, or you know what? Maybe I just haven't met the right person, because I've done a lot of it is talking to people, talking to the techs that are maintaining these RF links, and they're not always hams, but some of them are hams. You know, like discovering that Baynet has a 3 gigahertz link, that they're utilizing the spectrum already. You do find that there are other hams, even for Mount Diablo. Discovered that there's 3 gigahertz being used to get internet up there for a few of the for the ATV, you know, and for Trevor for his system that's up there. So, but there's a lot of microwave links. So, and some of this, no, I have not. I can see this. I can see the dishes, but no, I do not have a layer, because I kind of have to assume that the internet is something that is there that we can use to tunnel in people from a distance. But if there were a disaster, that internet might go away. So that tunnel, you know, the tunnel is there to get people involved in the mesh, the grayer lines. But where AT&T has its sites, you know, things like that. Ubiquity does do one thing. They try to sell you tower sites, so they'll let you know if there's existing microwave infrastructure, and we're lucky that a lot of the sites do, but that's for commercial. You know, if you want to buy into bandwidth or buy into wireless, the Bay Area has a number of wireless service providers. Monkey Brains in San Francisco. They're moving in. They're growing into the Bay Area. I believe they're targeting the East Bay for some rollouts. But the Central Valley and the coasts of California are completely dependent on wireless internet service providers, because AT&T has not done their due diligence to bring fiber optics into those communities. So they're relying on some of that. But that's within the commercial realm, where you've got to really have a dialogue. Where are your links? You know, are they sharing them? There's a lot to discover there, but for the most part, when building the mesh, it is only what you know. So if there's a link that you need to build redundancy around, then you gotta be diligent to find it and know.
We're going to take 2 more questions, and that'll be it for the night.
Okay.
So raised hand. We need to see a raised hand if you have a question for Matheson, please.
We have a question in the chat window. So from Justin Kogel.
Yeah, more of a comment. I believe the power ham can provide is the alternative path utilizing more paths in obscure locations.
Certainly. Yeah.
Okay. Last questions? Okay, our fearless leader. I don't see anything, so take her away.
All right. Well, thank you, everybody. That was a very, very, very detailed presentation. Thank you, Matheson, and very nice slides. Jan, I'm going to turn it over to you.
Okay. All right, Larry. So I guess this is concluding our meeting. So thank you very much, everybody, for attending. Thank you, Matheson, for excellent presentation about something that I really wasn't aware of, and many others I'm sure were not aware. So feel not really sure what next, just chat for a little bit, and this concludes our meeting at about 20:54.
Yeah, and we'll be seeing Matheson an appreciation item, correct?
That's correct. That's correct. We have a little gift and also a certificate of appreciation and gift certificate.
And just to let everyone know, a copy of Matheson's slide deck will be linked to from the speaker page under his name there, under his description. So that'll be done probably sometime tomorrow. So if you want to take another look at his slides, you can go there and click on the link.
So Mike, will you be doing showing the chat, sending the chat out?
Normally I haven't done that for these meetings.
Well, that's okay.
If anybody wants to, they can save their own chat.
Yeah, because it does have the presentation in there, correct?
It does now. Matheson just reposted it. He posted it early, but people who came in after that wouldn't have gotten it. But yeah, now, so save your chat, and that's another way to get it. If you don't know how to do that, speak up now, and we'll talk you through it.
Okay. So Matheson, was what you put in the chat, was it your presentation, or was it the images that you were kind of showing before 7 o'clock that were when you were kind of looking on through screen share?
No, those are, I provided the slides. So that is a PDF.
Okay. All right. Okay. Thank you. Just want to make sure what I just saved to my desktop. So, well, thank you very much. I take it that's your new home behind you in Mars. Is that correct?
A little cold, but I've got lots of power.
All right. I'm going to close the meeting then, and thank you everybody for attending. Again, you're welcome to attend our board meeting on the 1st of March, and look forward to when I see you next. So 73, y'all.